a standard 120 volt electrical system, you have two main conductors: the phase conductor, often black or red, and the neutral conductor, usually white. These carry alternating current, or AC, where the voltage goes back and forth between positive and negative values. Now, if the neutral conductor becomes open, meaning it's disconnected, it breaks the circuit, stopping the current flow. But this can create a hazardous situation. Even though the circuit is broken, the voltage in the phase conductor can rise to 220 volts. This happens because the phase conductor remains connected to the power source, while the neutral is not. As a result, the voltage on the phase conductor can significantly increase, about twice its normal level. This can cause electrical equipment to fail or even start to fire, so it is a serious safety issue. Next, let's discuss voltage drop. Voltage drop happens when the voltage in an electrical circuit decreases as the current moves through it. This decrease is due to the resistance of the conductors within the circuit. The higher the resistance, the greater the voltage drop. Voltage drop causes heat from increased resistance in two main ways. Firstly, increased power loss. When voltage drops, some electrical power is lost as heat. The energy that should power the electrical device gets converted into heat within the conductors. Secondly, increased current. Voltage drop can lead to an increase in current flow. Electrical devices try to pull more current to make up for the reduced voltage. This increased current can cause the conductors to get too hot, potentially leading to a fire. Because of these reasons, minimizing voltage drop in electrical circuits is essential. This is achieved by using conductors with sufficiently low resistance. In an electrical circuit, the conductors such as wires offer opposition to the flow of current. This opposition is what we call resistance, and it is measured in ohms. The amount of resistance depends on the material of the conductor, its length, and its cross-sectional area. Good conductors, like copper and aluminum, have low resistance, while insulators, like rubber and plastic, have very high resistance. Now, a voltage drop is the reduction in electrical potential or voltage along a conductor through which current is flowing. It is a natural consequence of resistance. According to Ohm's law, voltage which is represented by volts equals current which is represented by amps multiplied by resistance which is represented by ohms, or volts equals amps times ohms. This tells us that as current flows through a resistance, there will be a voltage drop across that resistance. The amount of voltage drop is directly proportional to the current and the resistance. Several factors can influence voltage drop in a circuit. These include the length of the conductor, the cross-sectional area of the conductor, the material of the conductor, the current flowing through the conductor, and the temperature of the conductor. Longer conductors have higher resistance, which leads to greater voltage drop. Conductors with a smaller cross-sectional area also have higher resistance, resulting in more voltage drop. The material of the conductor affects its resistance. For instance, copper has lower resistance than aluminum. Higher current flowing through a conductor increases the voltage drop. Finally, temperature can affect resistance, as resistance generally increases with temperature. Voltage drop can lead to several problems in electrical circuits. It can cause lights to dim, motors to run slower, and appliances to malfunction. In extreme cases, it can even damage equipment or create a fire hazard. Therefore, it's important to manage and minimize voltage drop to ensure efficient and safe operation of electrical systems. To minimize voltage drop, you can use conductors with larger cross-sectional areas, which reduce resistance. Shorter conductors also reduce resistance and voltage drop. Choosing materials with lower resistance, such as copper over aluminum for certain applications, can help. Reducing the current in the circuit can also decrease voltage drop. Ensuring proper connections and avoiding loose connections can minimize resistance and voltage drop. You can also use voltage regulators to maintain a stable voltage supply to sensitive equipment. To calculate voltage drop, you can use Ohm's law: volts equals amps times ohms. However, for more complex circuits, you might need to use circuit analysis techniques, such as Kirchhoff's laws. There are also online voltage drop calculators and software tools that can help you estimate voltage drop in various scenarios. These tools typically take into account factors like conductor length, wire gauge current, and voltage. It's important to note that electrical codes and standards, such as the National Electrical Code or NEC, provide guidelines and limitations on voltage drop in different types of circuits. These codes are designed to ensure safety and prevent equipment malfunction. For example, the NEC typically recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. When designing electrical systems, it's essential to adhere to these standards to maintain safe and reliable operation. Regarding open neutrals, consider a multi-wire branch circuit, which is a 120/240 volt circuit. These circuits share a common neutral conductor. If the neutral becomes open, the voltage on the two 120 volt circuits will become unbalanced. The side with the higher load will have lower voltage, while the side with the lower load will have higher voltage. In a worst-case scenario, one side could reach close to 240 volts. This can damage or destroy sensitive electronic equipment connected to these circuits. An open neutral can also create a shock hazard. Normally, the neutral conductor is at or near ground potential, but if it opens, it can float to a higher voltage, potentially posing a risk of electric shock if someone touches it. To prevent open neutrals, it's crucial to ensure that all neutral connections are properly made and tightened. Regular inspections of electrical panels and outlets can help identify and correct loose connections before they cause problems. Using high-quality electrical components can also reduce the risk of neutral connections failing. Grounding is also a critical safety measure in electrical systems. The grounding system provides a low-resistance path for fault current to flow back to the source, which helps to trip circuit breakers or ground fault circuit interrupters or GFCIs and quickly disconnect the circuit in the event of a fault. This reduces the risk of electric shock and equipment damage. The grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel. From there, a grounding conductor runs to each outlet and electrical device. This conductor provides a path for fault current to flow back to the panel and trip the breaker. Ground fault circuit interrupters or GFCIs are another important safety device. They are designed to detect even small amounts of current leakage to ground, which can indicate a potential shock hazard. When a GFCI detects a ground fault, it quickly trips the circuit, cutting off the power and preventing a shock. GFCIs are typically installed in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Electrical safety is paramount. Always turn off the power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you're not comfortable working with electricity, it's best to hire a qualified electrician. Regular electrical inspections can help identify potential hazards and ensure that your electrical system is safe and up to code. Remember, electricity can be dangerous, so it's essential to take precautions and follow safety guidelines. Understanding the principles of voltage drop, open neutrals, and grounding can help you maintain a safe and efficient electrical system. Always consult with a qualified electrician for any electrical work or if you have any concerns about electrical safety. Electrical codes and regulations vary depending on your location, so it's important to be familiar with the specific requirements in your area. Ignoring these codes can lead to unsafe conditions and potential legal issues. Proper wiring techniques are crucial for ensuring electrical safety and preventing problems. Always use the correct wire size for the intended application and make sure all connections are secure and properly insulated. Avoid overloading circuits, as this can cause overheating and potentially lead to a fire. Use surge protectors to protect sensitive electronic equipment from voltage spikes and surges. These devices can help prevent damage to computers, televisions, and other appliances. Be aware of the signs of electrical problems such as flickering lights, frequently tripping circuit breakers, and outlets that feel warm to the touch. If you notice any of these signs, it's important to investigate the issue and take corrective action promptly. Ignoring electrical problems can lead to more serious issues and potential hazards. Consider using energy-efficient lighting and appliances to reduce your electricity consumption and lower your energy bills. LED lights, for example, use significantly less energy than traditional incandescent bulbs and last much longer. When purchasing new appliances, look for the Energy Star label, which indicates that the appliance meets certain energy efficiency standards. Educate yourself and your family about electrical safety. Teach children not to play with electrical outlets or cords and to never touch electrical appliances with wet hands. Make sure everyone in your household knows how to shut off the power in case of an emergency. Keep electrical cords in good condition and replace any that are frayed or damaged. Avoid running cords under rugs or furniture, as this can damage the insulation and create a fire hazard. Use extension cords only temporarily and never overload them. If you need more outlets in a particular area, it's best to install additional outlets rather than relying on extension cords. Before digging in your yard, always call your local utility company to locate any underground utilities. This will help prevent damage to underground electrical cables, which can be extremely dangerous. When working outdoors, be aware of overhead power lines and maintain a safe distance from them. Never touch a downed power line, as it may still be energized. If you see a downed power line, report it to the utility company immediately. Remember, electrical safety is an ongoing process. By following these tips and staying informed, you can help ensure a safe and reliable electrical system for your home or business. Always prioritize safety and consult with a qualified electrician for any electrical work or if you have any questions or concerns. In summary, an open neutral can cause dangerous voltage imbalances in 120-volt circuits, potentially leading to equipment damage or fire. Voltage drop occurs due to resistance in conductors, resulting in power losses, heat, and increased current, which can also cause overheating. Minimizing voltage drop through proper conductor selection and circuit design is crucial for electrical safety and efficiency. By understanding these concepts and following safety guidelines, you can help maintain a safe and reliable electrical system. Remember to always consult with a qualified electrician for any electrical work or if you have any concerns about electrical safety.